like when I'm going through, just, feel free to pop them in there. Yes, Patrick, on the wall is the Elon Musk flamethrower. I just got that like a couple days ago. It's awesome. It's just fantastic. So that's what that is. Kind of a ridiculous place to put it in my room, but I really didn't have room for it anywhere else, so I figure why not. That's actually cool. I didn't know the webcam would like do widescreen like that. But yeah, sure. Yeah, cool. If everyone can hear me and everyone can see my screen, I guess let's get started. I have some links I'm going to dump in the chat right now for you guys. Let's see if that worked. Cool. This is just basically a collection of different links for Vminfod. So it has like the operator's guide, which has like a quick introduction if you've never seen it before. The RFD, if you really want to get into kind of the history of it and basically what the whole project was supposed to be and what it ended up being. The source code, majority of the source code is live, and that's what that is. But it's also in other places, various agents and stuff interface with the daemon. So majority of the source code will be there, but not all of it. Let's see, extra. If you man Vminfo on any Vminfod enabled machine, you'll get a nice little man page, some documentation about how to use some client software for it. And then the actual commit, that thing is gigantic. It's really gigantic. It's probably overwhelming. But if you want to see basically every single file that was touched in the platform for Vminfod, there it is. So yeah, I guess let's just jump into it. First thing I wanted to go over was kind of just like a high level, like what is Vminfod? And I guess the easiest way to say that is it's a daemon. That's what it is. It lives in the platform, so this will be in any global zone, compute node, head node, vanilla SmartOS, it doesn't matter. The platform will have this tool. Just like we have like a metadata agent or we have the VM daemon, we also have Vminfod now. So I'm gonna show you guys that real quick. This is a machine I have at home. The reason I'm logging into this machine is because it's vanilla SmartOS. There's no STC, there's no Triton, there's no anything fancy on it. So this just has some VMs that I run at home, like a DNS server and just like a whole bunch of other random stuff. But to show you guys real quick, let's see. To figure out basically if you have Vminfod on your machine, you can do SVCS Vminfod, and there you go. You see it's online. The Vminfo client tool is useful because you can ping the service. These are just thin little wrappers around HTTP requests. You could also do this manually if you wanted to, like that. Because Vminfod under the hood is really just a daemon. It listens on 9090, and it's responsible for gathering information about all the VMs on a machine. A VM could be a zone, it could be Beehive, it could be KVM. Its job is to get information about that, keep that information up to date, respond to events on the system to keep it up to date, and then just kind of expose it over an HTTP interface. Let's see. Okay. So Vminfo status, this is a cool command. This actually looks at the status interface that the Vminfod daemon has. The reason I want to start on a vanilla SmartOS machine is because it's very small. As you can see, I'll kind of go through it, but you can see it's in the state running, it's working. This is pretty much what you're always going to see Vminfod in. If it was in some sort of problem state, this would be updated, but majority of the time you expect to see that. It tells you the PID, because again, it's just a node process, how long the daemon's been running, how much memory it's using, how many VMs are on the machine. So this has 24 VMs. Vminfod uses a serializing queue. So basically as events come in from either like zone sys events or the file system or ZFS sys events, they all go through this serialization queue. And it basically tells you, okay, is the queue paused? Is it idle? How many tasks are pending? How many tasks are queued? Yeah, pretty much that. As you can see, this machine is not busy at all. So the Vminfod is pretty much just sitting here. The last refresh, every 5 minutes, Vminfod goes through and does a full refresh of the system. This is because sys events they're fire and forget pretty much from the kernel's point of view. So it's sort of like a best effort type of thing. Sys events, they're not really reliable. Something could happen, like a ZFS change could be made, or a zone event a zone could go through an event, but not actually have a sys event be emitted. So basically every 5 minutes we just go through and say, hey, let's just get the whole system, get a whole picture of the system and basically determine, were there any differences from what we think the system is and what the system actually is? And those are recorded in a log. You can find those in the log file. If anything's different, it'll emit a warning, stuff like that. But this part's cool. the events listeners. It's kind of confusingly worded, but it's events listener because there's an events interface with Vminfod. So if you basically do a web request to /events, it will keep your connection open and it will spit out new line separated JSON at you, which is every single event on the machine for every single VM on the machine as they come up. I'll show that later because it's actually really cool. But basically this just shows you who is currently listening for events on the machine. So you can see on vanilla SmartOS, we have the metadata agent. It is using Vminfod Watcher, which is the JavaScript class that it's using. This is the host name, the PID, and the actual program itself that's running. And then each event listener from Vminfod's perspective has a UUID. This makes it really easy to kind of track them in the logs if you think something's wrong. And you can see that this listener was made 7.5 days ago, which is pretty much the uptime of the daemon, which I'm willing to bet, yep, it's the uptime of the machine. Basically, these just run forever. They're always listening. So metadata and what is this one? VMADMD. These are always listening on Vminfod for events. In the past, they were using, I believe it was zone events, which use sys events under the hood. But now, actually, funny enough, VMADM still uses zone event, but it's actually a JavaScript wrapper now around Vminfod. So I realize this might be kind of confusing if you've never seen this before. Again, if you have any questions, please just post them in Mib if I'm going too fast or this is just kind of confusing or it seems kind of arbitrary, just let me know. Otherwise, I will show the cool stuff. And the cool stuff is what happens in, well, it was supposed to be Col, but I was having problems getting Col working, just weird networking problems. It was my fault, I was messing around with it. But so luckily I have Nightly 3, which I've done a lot of testing on. This was sort of the Vminfod test machine for the last couple of years. Sorry, the Zoom thing keeps coming up. Okay, so let's see. So on this machine, this is what it would look like if you were on a head node. Again, Vminfod runs on everything. It runs on a head node, runs on a compute node. So you can see VMADM list just gives you the output you expect, but under the hood, what it's doing is it's using Vminfod. Again, Vminfo ping, I can verify that Vminfod is actually running on here. So some cool things we can do. Let's see. You can look at the Vminfod logs, system smart DC Vminfod. And yeah, it's Bunyan logging, and there is a lot of logging. It's debugged by default, and as a result, a lot of stuff goes to this. But what we can do is we can filter it for any request coming in. And then what we can do over here is we can run VMADM list. And you can see that underneath it, Vminfod got a request for get VMs. So that's how VMADM list it works. It actually just does a get request on Vminfod, gets all of the cache data, and then formats it nicely. And the nice thing about this is if you have 10 VMs, if you have 20 VMs, or you have 200 VMs, it's pretty much going to return at the same speed. It always kind of feels instant, which is it's just very nice. If you were to do, let's say, pick a random VM and do a VMADM get, which will actually load the data specific to that VM, you can see over here that there was a request for get VMs and then the UUID. So again, the interface is really simple. Get VMs gives you an array of every VM in the system. Get VM/UUID will give you that specific UUID. And 404 if it's not found. It's just a really, really stupidly simple HTTP interface. But yeah, now we can actually start doing some cool stuff. So I think I have on this machine, let me make sure. Yep, I have this minimal JSON. So this will create a just a really simple Joyent minimal machine with a really simple, I want to say this is the newest image available, 64 megs. Like it's really just a small machine. But we can go over here, we can VMADM create it. And what we can do over here is as it's creating, we can do something really fun. We can do VMADM events. And what this will do is it hooks up to the /events interface and it will format them nicely. This is meant for an operator to run. This is not meant for a tool to consume by default. You can give it the -J option and that will output it directly in JSON. So there actually are some tools that use VMADM events under the hood. Also, I think there's a -R Yeah, the -R just kind of reports a ready event, basically saying like you are ready to start consuming events. So let's see, let's create this minimal machine and you should see events. There we go. Events just start flooding in. So the event output is pretty much the timestamp, the UUID of the machine, the alias, and then what we saw. So Vminfod has 3 types of event: create, modify, and destroy. I think it might actually be called delete. So you see the machine was created, and then you can see a bunch of modifieds happen. The zone state went from configured to incomplete, state changed, the quota was added, ZFS stuff was added, zpool was added, like a whole bunch of stuff changed here. And then we can go over here, vm destroy. What is that new machine? 4E7, there we go. And then over here, you can see the events as they come in live. And then finally over here, vm actually destroyed it. The events, zone state going to incomplete, state going to incomplete, and then finally the delete event here. So it's really cool. It's really useful if you're running like the test suite or you're on a machine, you really don't know what's going on. You can just run vm events and kind of just leave it open. And that will show you every modification to every VM on the system, no matter what happens, no matter how the modification happens. So even if someone tries to circumvent vm and go directly to like a ZFS command or a zone config command, if it affects the VM's JSON payload, it will be reflected in vm events, which is just super useful. So I can actually show that because it's kind of cool to see. Let me clear this. There. And then we'll do create the minimal machine again. And we can see, okay, cool. The machine is created. And then what we can do is we have this UUID here for the new machine. We can do vm update this UUID RAM equals 128. And then you'll see the change reflected over here. Now, a lot of things happen when you change the RAM. There's some keys under the hood, like max physical memory, max lock memory. Most of the time, these will be pretty close to what you're setting it to. KVM kind of does it differently. Beehive kind of does it differently. There's actually a bug right now with how Vminfod handles Beehive changes for changing the RAM, so I'm working on that actively. But it's cool. You can see the changes get reflected here. And then if I were to say, let's update it again to 128, nothing happens. The last modified change, but there's actually no change, and that's because Vminfod realizes changing from 128 to 128 will result in no effective change. There is no event that gets emitted. It still outputs successfully updated. This wasn't really my doing. This is just kind of how the system already worked. Like if you did this on a pre-Vminfod machine, the same thing would happen. Even if you set like kind of an arbitrary key, you'll get that. Yeah, you can kind of just like any sort of update you can do will work how you expect it to work. I think 10 was already the default quota. So if we change quota to 20, there you go, quota change from 10 to 20. But like I said, what you can do is you can modify it manually. And this is not exactly the best thing to do. You really shouldn't be doing this on like a live system. You should definitely be using the vm tools, because the vm tools are Vminfod aware. They won't return to you until Vminfod has seen the change. So this is kind of cool. When you do like a VM update quota, it'll run the ZFS set, and it will also wait for that event from Vminfod, and it will not return to you, an exit status of 0 until that change has been reflected. This is cool because if you were to do an update immediately followed by a get, the get would return the new value. There's no chance where you're going to get stale data back. So let's see. I think we can do ZFS set quota equals, what are we, 20, do like 30? There we go. So yeah, I said it was ZFS set, and then over here, you can see that the quota change was found from Vminfod. And the reason that happens is because Vminfod is watching for ZFS sysevents. And we can verify that too. This is actually, it's just really cool. If we tail the logs, our service logs, system, smartdc, Vminfod, 20-0 short. What I like to do too is I filter out requests. So any sort of incoming requests, sometimes systems are fairly busy. This just filters those out of the logs. So let's go up a little bit. All right, let's see what we can do here. We can do set the quota back to 30 and see what happens. I'm going to control C it so there's no more logs. As you can see, a lot of logs came in, but it kind of can explain how the daemon works under the hood. The first thing we get is the handle zpool event. So basically a zpool sys event came in with the dataset name of zones, the zone name that we changed. The action was set quota to that. The way Vminfod works is it doesn't inspect the payload of the sys event. This is really important. When the sys event tells you what has changed, Vminfod doesn't actually listen. It just queues that up and it knows, okay, I should go refresh the current state. So say we get a sys event for the zone transitioning to, I don't know, down. We don't listen to that. We just say, oh, the zone changed. Let's reload zone adium and kind of figure out what happened. Oh, the ZFS data set changed. Let's reload the ZFS data and see what happened. This is kind of cool because if we were to add new events, this actually happened right after Vminfod was launched. Mike Gertz added a new event. This is great for zone sys events, and Vminfod didn't need to be modified to handle it. It was just a new event came in, so Vminfod knew to queue up the action to go update its cache. Really useful that way. But yeah, let's see. So we handle zpool event. The event came in. This is what the actual sys event looks like from the ZFS side of things. It's actually kind of cool as a little bit of history here. When I took on the project, there were no ZFS sys events. I had to add that. But before that, there was this gigantic dtrace one-liner that would actually watch for the history event. So when the history was written, like zpool history, it would actually fire off a line from dtrace, and then the node daemon would capture that line and know that something was changed in ZFS and then go through and update its cache. So yeah, not great to have a persistent dtrace command running, but still really cool, and definitely a really cool bit of history. And it's one of those things when you see it, like when I saw it for the first time, I was like, wow, this is really impressive, really cool, and kind of shows off the power of dtrace. But yeah, back on task here. Let's see. So the queuing system, like I said, everything goes through a serialization queue. It has a bit of dedupe. So what it does is it looks for the description, which is handle ZFS. It has the dataset name, and it has the action it wants to go on, which is to fetch the new data, expire the old data, and copy the new data. Kind of Vminfod specific here. So there was no duplicate task found. It pushed it to the VA sync queue. It uses a VA sync queue under the hood. And then started the task. On a busier system, you'll notice an event come in, it'll get pushed to the queue, and then sometime later it'll get started. Because there was nothing happening here, it got started pretty much immediately. There were no other tasks waiting. So then it starts doing this task, executes this ZFS command, very big command to basically get everything about that zone specifically. Runs the ZFS command, exited with 0, refreshes the VM object, refreshes the zone data, kind of goes through just a whole bunch of stuff. This is the same output you would see with VM adium. This is using the same logic under the hood. How VM adium get and VM adium lookup used to work is how Vminfod works. It gets that information, and then VM adium is just a thin wrap around asking Vminfod what the current state is. So yeah, after it goes through the change, the last thing it does is it looks at what the old JSON payload was, what the new JSON payload is, calculates a diff, and then outputs an event. So anyone listening on the events listener interface will get a single JSON line, and this is the JSON line they'll get. Now, it's been pretty printed, but this is what they'll get. So you can see type modify, the date it happened, the zone name, the UUID. This is the VM, the entire payload of the new VM. So not how it used to look, but how it looks now. And then changes is an array of everything that changed. So you can see the pretty path, this is pretty much meant for printing. This will have dots and stars in it if it's an array. And then the actual path. The reason path is an array is because, say someone modifies the second disk, the second quota of the disk, or the disk array spot 2, the quota of it, you'll see the path will be disk null quota. Yeah, I'm not really explaining this well. But basically, this is just a way to know exactly what path changed and without having to use dots as a sort of separator. So technically in the future, if someone were to add dots to a key name, we would be fine here. So yeah, you can see the quota was changed from 40 to 30. And that's pretty much it. And then, okay, the task is done. So the queue says, okay, we've done our work, we finished it. And there's a whole bunch of debugging about that, which is really nice. So you can see like, it shows you when the task was created, when the task was started, and when the task was finished, and then the delta. So you can, there's so many different things you can calculate here. But you can say like, okay, I know this task only took this many milliseconds or whatever, and you can see that right here. So it shows you the task took this many milliseconds. You can see how long it takes from when you push a task onto the queue to when the task actually gets processed to when it actually finishes. There's just so much timing here. The reason for that is because when I was doing it initially, the queue library was homegrown. There wasn't a VA-sync queue back then. And there were so many timing issues. There were so many things that would just sort of hang indefinitely. There were things that would finish but wouldn't call back properly. And I'm not saying I inherited it bad. I'm saying like I even introduced my own bugs there. So that's why I threw in so many just debug statements, so much timing statistics. Like I want, basically, if you look at anything in Vminfod, you're going to see timing stats everywhere because there was so much stuff that would just sort of hang. I wanted to figure out, okay, why is this happening? Why is this happening so slow? How can this be faster? So yeah, there's pretty much, if you're looking through the Vminfod logs, you're going to see timing stats everywhere, which is just incredibly useful to see. So let's see. I guess the last thing I wanted to show was status-f. This gives you full status. I'll do FJ. So this is full status in JSON. This comes directly from the daemon. Full will give you more output than just a regular status. And this actually works on the daemon side of things. So you actually have to request full from the daemon, and then it does more work. It goes into like FS Watcher and stuff. I'll show that right now. So when you get full data, you get a lot. You get a lot. But you can see you get the PID, you get the uptime, you get the memory usage. Pretty much everything you saw in the original status is here, number of VMs, but you get so much more. So the last refresh happened 4.78 minutes ago, which means we're approaching the 5-minute mark, so another refresh is going to happen. Refresh errors, this is basically an array of any errors that were encountered during a refresh. So when you do a full refresh of the system, it's possible to encounter an error. This is rare, in my opinion, in my experience. But this actually is it's kind of cool because the fact that you can experience an error here means that on a pre-Vminfod machine, you can experience an error doing a VM-ADM list or a VM-ADM lookup. That's totally possible. So for instance, if you were to do a VM-ADM lookup, you get every single UUID of every instance out there, and then you go through one by one and get the information for every VM. If a VM were to be deleted in the time from when you got the initial list to when you looked up its information, that would result in a refresh error. So it's a timing thing, it's a race thing. We don't do anything with refresh errors except log them and try again, because that's just something that can happen on the system. It's inherently racy here. I never really encountered this myself. It wasn't until Isaac came along and started testing this where we started noticing just some weird errors around this. And it was actually my testing on his machine with like just hundreds of VMs, just so many VMs, thousands, that I started noticing these refresh errors. And before they weren't logged, they would just crash the daemon. And it was kind of crazy. Let's see, the last thing, you got event listeners here. This is the same output you saw before. The refresh log, this is slightly different than the refresh errors. These are changes noted during a refresh. So basically, when a refresh happens, we're hoping that what the current system looks like and what we think it looks like are the same, but sometimes those are different. And what we do is we'll log every single difference, and there are two types of differences. There are the cache changes, so this is the internal cache object that Vminfod uses, and then there are the VM changes. So the cache changes are things like, oh, this snapshot was here. The snapshot was removed. We didn't catch the snapshot was removed, but the snapshot was removed. But did that result in an actual VM change? The answer is no. What that means is none of the VM JSON payloads were actually changed as a result of this change. So we didn't have to notify any subscribers that there were any changes because nothing effectively changed. Yeah, I know it's kind of confusing and it's a lot, but this just sort of goes over just basically the full status output. FS Watcher is cool. You can see every single file that's being watched. So Vminfod watches every single one of these files for changes. And if there are changes, it'll go through and do whatever updates are necessary. So if the zone file changes, it'll do a full zone ADM refresh. If the tags file changes, it will reload just the tags, things like that. The not yet watching, this means that file doesn't exist, but we keep trying to watch it. Eventports doesn't let you watch a file that doesn't exist. So basically the JavaScript land is just kind of retrying to see if that file exists. When it exists, it will start watching it. The watcher is just a C program, so it has its own PID. If there's any pending actions, this should pretty much always be empty, but the FS Watcher works by sending commands over standard in and getting output over standard out. So that's how the node program communicates with it. And then one final thing I want to show, just to kind of show how this works, is when you run Vminfo status, you have your events listeners here, and you can see how different things are listening for events. So on a machine with Triton, you have like 7 different things right here. What we can do is we can add to that list. We can run VM events and then rerun status over here, and we can see right here, 2.2 seconds ago, VM.js events from the VM CLI on this machine with this PID, with this program, and this unique UUID was created 2 seconds ago. So this is another events listener. And what's cool about that is, I'm trying to remember how to do this. I think if you use the node VM wrapper, it will set this for you. So I could say something like this. And then if I rerun that status command, you'll actually see that show up right here. And this becomes super useful because when I look at the event listeners, I can say, oh, okay, the VM CLI is running here as part of NetAgent, VM events, finite state machine. So you can kind of really get just like a ton of debugging, a ton of transparency, basically figure out what is listening, what program is listening, what daemon is listening. And how this actually works under the hood is super simple, like super simple. If I were to just curl this, it's going to give a lot of output. But if I were to curl this and then run vminfo status, you can see that curl shows up. So it's nothing more than the user agent. That's all it is. So if you were to do, I think it's user agent foobar. There you go. So it just shows foobar right here. So pretty much whatever you set as the user agent will get set as the sort of identification in Vminfod. And if you use the client library, so the Vminfod client library node vmadiumd, it pretty much gives you a name property you can set, and then it will wrap it around all the other stuff you see. So it'll automatically put the host name, the PID, the name of the executable, which I think is just argument 1 or argument 2 of the process arguments. So it'll kind of do all that nice stuff for you. You don't really need to be setting any of this stuff manually. So yeah, that was most of what I had. I hope it wasn't too meandering. Oh yeah, no, I haven't done any sort of like sanitation or verification of what you send in. So feel free to send in some fun stuff over curl and just see what happens. I mean, if you can get Vminfod to crash, then please do it and file that bug and we can fix it. So I haven't really messed around with sending too much stuff over that. So that'd be good to know. But yeah, that's pretty much all I had. You got the documentation, all the links I set. Hopefully this kind of, helped cleared up some of the stuff around it and just kind of showed how it works. Like I said, it's on every platform. It's going to be, compute node, head node, vanilla SmartOS, basically everything's going to be running Vminfod now. And yeah, hopefully it just works. Basically one of these things is you shouldn't have to know it's there. As long as you just keep using the VM tools, everything should just work. It should just be transparent. Yeah, there have been some growing pains specifically around Beehive, but just working through those as they come up. So yeah, any questions for me? Any sort of like clarifications, comments? So I have Mib open. Yeah, honestly, I'd be really curious to see how it handles setting a user agent like that. Well, you can print colors, so that's kind of neat. Yeah, I should probably do some sanitization. Now, I bet the daemon's probably fine. This is just the vminfo status command that probably could be cleaned up. If I were to run it through something that strips those off, I'm sure it'd be fine. But yeah, that's interesting. So that's cool. Probably should put some, sanitization in the client libraries, but that's definitely fun. Seriously, any way you guys can think of breaking it, please try to break it. It'd be fun. And then we'll make an issue and then we'll fix it and we'll just make this thing better.
Thank you, Dave.
Yeah, thank you. Great.
Awesome. Great. Yeah, thank you. Stop the